70 kilometers off the coast of Belize, in the middle of the Lighthouse Reef Atoll, there is a circle in the ocean. It is 318 meters wide and 124 meters deep. From the air it appears as a dark disk of impossible navy blue surrounded by the turquoise of the Caribbean Reef, a geological punctuation mark in the middle of one of the most biodiverse marine ecosystems on Earth. From underwater, at the rim, it looks like the edge of the world. Below the reef shelf at 3 meters depth, the limestone drops vertically for 124 meters into darkness. There is no gradual slope. There is no transition zone. There is reef and then there is nothing. The Great Blue Hole formed 153,000 years ago as a terrestrial limestone cave, a karst dissolution feature produced by slightly acidic groundwater eating through the calcium carbonate bedrock of what is now the Belize continental shelf. Rainwater absorbs carbon dioxide from the atmosphere and soil, forming carbonic acid. Carbonic acid dissolves calcium carbonate. Given enough time, in this case tens of thousands of years, the dissolution produces caves, tunnels, and chambers inside the limestone. The cave that became the Great Blue Hole was one of these. A large subterranean chamber with a ceiling of limestone and a floor that descended to what is now 124 meters below sea level. When the last ice age ended and global sea levels began their 120-meter rise over approximately 10,000 years, the cave flooded. The ceiling, unsupported by the air pressure it had relied on and now subjected to the weight of seawater above, collapsed. The collapse was not a single catastrophic event. The multi-beam sonar data from the 2018 Aquatica expedition shows a primary floor at 124 meters and a secondary depression in the southern quadrant reaching 127.2 meters, indicating at least two separate collapse events of different ages. The primary collapse created the hole. The secondary collapse, its date unknown, its cause unexplained by any published geological model, created a bowl within the bowl, a mystery inside the mystery. What the first underwater explorers found when sport diving reached Belize in the 1970s was this: a perfectly circular opening in the reef, 318 meters in diameter with less than 4 meters of deviation around the entire perimeter. The uniformity of the circle implies a radial fracture symmetry in the underlying limestone that does not appear anywhere else along the 300-kilometer Belize Barrier Reef. At 15 to 42 meters depth on the inner walls, stalactites. Stalactites can only form in dry air, from the slow drip of calcium carbonate-saturated water falling from a cave ceiling. Their presence underwater, perfectly preserved, up to 4.2 meters in length, chalk-white calcite against the dark blue water, is the physical proof of what this place once was: a dry cave above sea level in an ice age landscape that no longer exists. Every stalactite in the Great Blue Hole is tilted 5 degrees toward the south-southeast. Every stalactite, every wall, every azimuth. This means the entire limestone platform rotated as a single rigid body, 5 degrees, after the stalactites formed and before or during submersion. The tectonic event that caused this rotation has not been identified, mapped, dated, or named in any published geological literature. The Caribbean plate boundary is 200 kilometers to the east. There is no mapped fault system in the Lighthouse Reef Atoll that predicts a coherent 5-degree rotation of the shelf. The stalactites are the only evidence. They hang at 5 degrees from vertical, in 22 degrees Celsius water, at 35 meters depth, waiting for an explanation that has not yet arrived. Jacques Cousteau visited the Great Blue Hole in 1971 aboard the Calypso and declared it one of the top 10 dive sites in the world. He filmed the stalactites from a small submarine. He called them magnificent. He was correct. What he could not have known, what required 47 more years of technology before it could be measured, is that the hole beneath the stalactite zone contains a sealed anoxic water column, a 15,000-year sediment climate archive, and a chemical environment that has been undisturbed since the Bronze Age. The magnificent part was the entrance hall. The library was below it in the dark, waiting. The floor of the Great Blue Hole was first reached by a human being and documented with scientific instruments on December 2, 2018, when the Triton 3303 submersible from the research vessel Alucia descended to 124 meters depth. The dive lasted 53 minutes. In those 53 minutes, the crew collected sonar data, visual documentation, and water samples that changed what oceanography knows about this formation in ways that took 4 subsequent expeditions and 6 years of laboratory analysis to fully quantify. The descent from the surface to the floor passes through 4 distinct environments that are as different from each other as desert is from ocean. From the surface to 15 meters, the living reef zone. Coral heads, sponge formations, parrotfish, surgeonfish, the Caribbean reef ecosystem in full biological operation. From 15 to 42 meters, the Stalactite zone. The reef falls away and the limestone walls begin, hung with the chalk-white formations that mark the boundary of the last ice age's sea level. In this zone, at exactly 42 meters depth, the last stalactite ends. Below this depth the cave was always submerged, even at the coldest point of the glacial maximum, and no stalactites formed. The boundary is not gradual. It is precise. The last stalactite ends at 42 meters. Below it bare wall. From 42 to 89 meters, the biological void. No coral. No fish. No plankton visible at depth. The water is clear Caribbean seawater, oxygenated, blue-black in the failing light, and biologically empty. A diver passing through this zone on compressed air at depths below 60 meters is experiencing nitrogen narcosis, cognitive impairment from the elevated partial pressure of nitrogen at 7 atmospheres, that renders their judgment equivalent to legal intoxication. The water is doing nothing to them. The physics is, at 90 meters, the halocline. This is the most significant feature in the Great Blue Hole and one of the most precisely defined chemical boundaries in the Western Hemisphere. In a vertical distance of 35 centimeters, dissolved oxygen drops from 2.1 milligrams per liter to 0.0 milligrams per liter. Simultaneously, hydrogen sulfide rises from 0.0 to 4.2 micromoles per liter. Salinity increases from 36.8 to 37.4 psu. Temperature increases by 0.4 degrees Celsius. A temperature inversion, warm water below cooler water, stabilized by the higher salinity preventing convective mixing. This boundary has held at 90 meters depth for an estimated 3,000 years. The Caribbean circulation that oxygenates every reef in the Western Hemisphere stops here, at this line, maintained by density physics alone. Below 90 meters, the anoxic zone. No dissolved oxygen. Active hydrogen sulfide. A pale amber tint to the water from dissolved organic compounds and reduced iron. No biological life visible to any optical instrument, with one exception, documented for the first time in 2024. A thin white filamentous bacterial mat at 95 meters depth, identified as Beggiatoa sp, a sulfur-oxidizing chemolithotrophic bacterium that derives energy from hydrogen sulfide oxidation. This mat, the only living organism in the entire water column below 90 meters, produces a faint chemiluminescence detectable by calibrated cinema sensors. In the complete darkness of the anoxic zone, it is the only light source. It has possibly been glowing there for centuries. The floor at 124 meters is pale beige sediment, finely laminated, carrying a 15,000-year annual record of Caribbean climate. Each lamination pair, pale carbonate over dark organic, represents 1 calendar year of marine productivity. The younger Dryas cold reversal appears as 2.2 centimeters of compressed darker laminations. The most recent lamination, 2024, is the highest carbonate anomaly in the record, the highest recorded marine productivity, corresponding to the highest recorded sea surface temperature, in 15,000 years of Caribbean history. The sediment floor is still recording. The record is getting worse. Between 1997 and 2012, an estimated 200 divers died at the Blue Hole in Dahab, Egypt. The Egyptian government maintains no complete public fatality count. The number comes from the incident records of the Dahab Diving Safety Association, cross-referenced against hospital admissions in Sharm el-Sheikh. The local dive guides have called it the Divers Cemetery for decades, a name that predates any tourism marketing and emerges simply from the fact that people enter and do not return. On April 28, 2000, Yuri Lipsky, 22 years old, descended alone into the Dahab Blue Hole with a helmet-mounted camera and insufficient technical certification for the depth he was attempting. He reached 115 meters. The recovered footage is 3 minutes and 21 seconds long. At 115 meters on compressed air, nitrogen narcosis produces cognitive impairment equivalent to 5 times the legal intoxication limit for operating a vehicle. The footage shows a diver attempting to operate his buoyancy compensator correctly and failing. His body was recovered from 115 meters on the same day. He is one person in approximately 200. The Great Blue Hole in Belize maintains no public fatality registry. The Belize Maritime Authority's incident records from Lighthouse Reef Atoll between 1980 and 2024 are not consolidated into a published database. Dive operators at Ambergris Cay and Cay Caulker estimate, informally and consistently, that fatalities occur at a rate of 2 to 4 per year, the majority attributable to narcosis below 40 meters, buoyancy control failure, or equipment failure at depth. The majority receive no international news coverage. The recoveries take hours. The incident reports go to the Maritime Authority. The next dive boat has already anchored at the rim. What the body undergoes at 68 meters depth on compressed air. At 6.8 atmospheres, nitrogen partial pressure reaches 5.31 bar. At these levels, nitrogen crosses the blood-brain barrier and produces narcosis, a dissociative neurological state that impairs spatial reasoning, depth perception, time awareness, and the ability to correctly execute practiced physical sequences. Studies by DCAM in Toronto found that 40% of test subjects at 60 meters on compressed air could not complete a simple three-step problem-solving task. Buoyancy compensation at 68 meters requires a precisely calibrated sequence of actions. In a narcotic state, the sequence fails. The diver descends. Descent deepens narcosis. The sequence fails further. The weight belt recovered from the 68-meter limestone ledge in the Great Blue Hole on the afternoon documented in this film contained 8 kilograms of lead. The quick-release buckle that could have jettisoned it requires a specific hand motion, practiced until automatic, then erased by narcosis. The shearwater dive computer recovered from the same ledge showed a maximum depth of 68.3 meters and a total dive time of 5 hours and 14 minutes. It was still recording on its last battery bar when the ROV found it. Its low battery alarm had been pulsing at 8-second intervals into the darkness for hours. No one above the halocline could hear it. The recovery required 2 Belize Coast Guard technical divers on trimix gas, a 300-kilogram lift bag, 42 minutes of staged decompression on ascent, a Zodiac RIB, a Bell 206 helicopter, and a Sked rescue stretcher. Total in-water time for the recovery team, 55 minutes. The subject had been in the water for 3 hours and 47 minutes when found. The Great Blue Hole does not kill with force. It kills with physics and chemistry operating at the precise specifications of what a human body on compressed air cannot withstand. The stalactite overhang that held the diver at 68 meters formed 153,000 years ago. It did not move to catch anyone. It was simply there, at the right depth, at the right angle. Everything else was physics. The Great Blue Hole is not primarily a dive site. It is a scientific instrument that the Earth assembled 153,000 years ago and has been operating continuously without interruption or calibration ever since. The data it contains, in its walls, in its water chemistry, in its sediment, represents one of the most complete, precisely dated, and difficult to access natural archives on the planet. The difficulty of access is not incidental to its scientific value. It is the reason the archive exists. The 5-degree tectonic tilt of the stalactite field is the oldest open question. Every stalactite, every wall, every azimuth. 5 degrees toward the south-southeast, a coherent rigid body rotation of the entire limestone platform that postdates the stalactite formation and predates or coincides with submersion. The evidence is unambiguous. The cause is unknown. The Caribbean plate boundary is 200 kilometers east. There is no published fault model for the Belize carbonate platform that accounts for it. It has been visible to underwater cameras since 1971. It has not been explained. The halocline at 90 meters depth is maintained by a 0.3 knot downwelling current in the oxygenated water above it, but the ADCP data from the 2024 deployment shows that this downwelling stops completely at the density interface. The anoxic zone below is not receiving new water from above. It is sealed. Yet the temperature inversion documented between 85 and 88 meters, warmer water sitting below cooler water, stabilized by elevated salinity, suggests a localized heat source at or below the halocline. A geothermal contribution to the hole's thermal structure would represent a previously unknown low-temperature hydrothermal system in the Belize carbonate platform. Mbari proposed a targeted investigation in 2023. Funding remains unconfirmed. The Beggiatoa bacterial mat at 95 meters, documented for the first time in 2024, is chemosynthetic, deriving energy from sulfur oxidation with no requirement for sunlight, photosynthesis, or connection to the surface ecosystem. Its species composition, biomass, metabolic rate, and establishment date are all unknown. It may have colonized the anoxic zone from spores in the overlying sediment. It may have been there for centuries. It is the only life in the dead zone and science has not yet formally described it. The secondary depression in the southern quadrant floor, 3.2 meters deeper than the surrounding floor, 40 meters in diameter, sharp-edged, formed between 2018 and 2024, is the newest unknown. The leading hypothesis is subsediment methane clathrate dissolution, methane hydrate in solid ice-like form, stored in the limestone beneath the sediment, beginning to destabilize and vent as gas through the sediment, displacing it upward and outward to form a pockmark. The methane sensor data from the 2024 ROV deployment at 127.2 meters, 31.7 micromoles per liter dissolved methane in the sediment pore water, 15 times background seawater concentration, is consistent with active methanogenesis or upward methane migration. This does not confirm clathe rates. It confirms that something is producing anomalous methane at the bottom of the anoxic zone of the most studied blue hole on Earth, and no published model predicted it. The 23 Hz acoustic signal recorded at 5:17 a.m. on January 14, 2024, by the ADCP hydrophone at 112 meters depth, minus 64 decibels, repeating at 7-second intervals, sustained for 4 minutes and 11 seconds. Not biological. Not current-driven. Not instrument artifact. 18 decibels above the instrument's own noise floor. No vessels within 10 kilometers at the time of recording, confirmed by AIS data. The signal has not been explained by Dr. Quattrini, Dr. Olak, or any specialist consulted since. It is in the data. It happened once. The ocean is full of unexplained sounds. This one happened at 112 meters depth in an anoxic sealed chamber where nothing should be producing a signal at all. At 4:23 a.m. on January 14, 2024, the Aleutia's hull-mounted Simrad EK-80 scientific echo sounder recorded an anomalous biological return inside the Great Blue Hole at 80 meters depth. Target strength, minus 12 decibels at 38 kHz, consistent with a large aggregation of marine organisms between 4 and 6 meters in equivalent sphere diameter. The return appeared at 4:23 a.m., remained detectable for 11 minutes, and disappeared from the sonar record at 4:34 a.m. No ROV was in the water. No acoustic telemetry tag produced a matching return. The target strength, depth, and behavioral profile, 11 minutes stationary at 80 meters inside the hole, then gone, has not been matched to any identified species or aggregation type known to occur at this location. The Great Blue Hole is biologically active in ways that daily dive tourism has never documented because diving occurs between 8:30 a.m. and 12:30 p.m. and the hole's most significant biological activity happens at night. The Noctiluca scintillans bioluminescent bloom that lights the hole's interior blue-white from surface to 30 meters depth every night after sunset. The Caribbean reef squid aggregations at 30 meters depth at dawn, their chromatophores producing rapid communication sequences in the pre-dawn darkness. The bioluminescent outlines of sharks and schools of silversides moving through the dinoflagellate field, their bodies traced in living blue light as they displace the cells. The moray eels hunting along the stalactite walls at 3:30 a.m., leaving luminescent afterimages of themselves in the water. None of this appears in any published biological survey of the Great Blue Hole because published biological surveys are conducted during daylight dive windows. Caribbean reef shark BZR0047 has been documented circling the Great Blue Hole's rim at 40 meters depth on every survey conducted by the Belize Shark Research Program since its tagging in March 2022. Its acoustic telemetry record shows it completing between 12 and 22 circuits per day, swimming the 318-meter perimeter continuously, never descending below 42 meters, the exact depth at which the last stalactite ends and the bare biological void begins. Whether the shark is responding to the hole's geometry, its acoustic properties, its thermal structure, or the chemical signature of the halocline 48 meters below its circuit depth is unknown. Whether it can detect the hydrogen sulfide from the anoxic zone from that distance is unknown. Whether its behavior is unique to this individual or representative of a population-level response to this specific formation has not been studied. It has been circling for at least 2 years of documented observation. It was almost certainly circling before the program began. The Nassau grouper using the stalactite overhang at 38 meters depth as a refuge habitat. The spiny lobster in the crevice at the base of the 4.2-meter stalactite. The 3 bull sharks on the southern wall at 20 meters depth with no prior documentation at this site. The spotted eagle ray formation entering through the eastern channel at dawn and descending to the stalactite zone, doing something there for 15 minutes before ascending. The hawksbill sea turtle BZHB0091 returning to this specific location on 34 of 58 tracked months. Every animal in this hole is using it for a reason. The reasons in most cases have not been identified. The hole is a refuge, a feeding ground, a navigation landmark, a spawning aggregation site, a thermal refuge, or some combination of all of these simultaneously, and the science to distinguish between these hypotheses has not yet been done. The Beggiatoa mat at 95 meters is detectable from 88 meters depth. Above the halocline, has a faint blue-white chemiluminescent glow visible through the density interface in zero ambient light. This means the bacterial mat's light production crosses the halocline boundary. Whether marine animals at 80 to 88 meters depth can detect this glow, whether it serves as a visual cue for the reef shark circuit depth, for the squid aggregation position, for the 4:23 a.m. sonar anomaly, is a question that has not been asked in print. The glow has been there every night. The animals have been there every night. The connection, if it exists, has not been documented. This is what the frontier of knowledge looks like in one of the most visited dive sites in the Western Hemisphere. Not in the unexplored deep, but in the water column of a tourist attraction at night in the dark, where no one has yet pointed a calibrated instrument. The Great Blue Hole does not require our understanding to continue existing. For 153,000 years it has been forming, recording, and preserving without human knowledge or assistance. The stalactites grew in air that no human breathed. The halocline formed before the first Mayan settlement on the Belize coast. The Beggiatoa mat has been producing sulfur chemistry and faint biological light in the anoxic zone since before the Half Moon Cay lighthouse was built, before Columbus crossed the Atlantic, before the Roman Empire reached its borders. The sediment floor has been recording Caribbean climate since the last ice age ended and civilization began. None of this needed us. What needed us was the knowledge of what it means. The understanding that the sediment laminations are a climate archive, that the halocline is a chemical seal with a thermal tolerance threshold, that the tectonic rotation recorded in the stalactites represents an unmapped seismic event in the Belize carbonate platform, that the methane anomaly at 127 meters may represent the first observable surface evidence of subsediment clathrate destabilization in the Caribbean, that the fastest warming rate in 15,000 years of sediment record is happening right now in real time while the instruments are still in the water. The numbers are these. The Great Blue Hole entrance fee is $40 per diver. The annual conservation budget for the entire Lighthouse Reef Atoll Marine Reserve, a UNESCO World Heritage Site, is $380,000. The International Monetary Fund's 2023 estimate of global fossil fuel subsidies, including explicit subsidies and implicit subsidies from unpriced climate, pollution, and congestion externalities, is $7 trillion. For every dollar spent protecting the reef that surrounds the 15,000-year Caribbean Climate Archive, $18.4 million are spent accelerating the warming that is destroying it. The fish biomass on the Great Blue Hole's rim has declined 46% in 10 years. In a no-take marine reserve, with a ranger station 1.2 kilometers away. The warming driving bleaching events and restructuring the food web is not a local problem addressable by local conservation measures. Ranger ELSA Tech's monitoring transects, conducted every quarter for 7 years, are among the most detailed biological records of any blue hole site in the world. They document a consistent decline that no amount of ranger presence can reverse. The entry fee funds the rangers. The rangers cannot change sea surface temperature. Under the IPCC's SSP 5-8.5 high emissions scenario, the Lighthouse Reef Atoll reef ecosystem will experience bleaching threshold temperatures for 14 to 18 weeks annually by 2074. The coral reef that currently surrounds the Great Blue Hole, the aquamarine shallow water, the diverse reef structure, the rim habitat for the horseye jack schools, the hawksbill turtles, the eagle rays, will be functionally collapsed under this scenario before the end of this century. The hole itself will be unchanged. Its depth, its stalactites, its sediment. The abyss is not threatened by warming. The reef around it is. The hole will outlast its ecosystem. The halocline may not. If Caribbean surface temperatures rise 2 degrees Celsius and the tidal breathing documented by the 2024 Logger Array begins to allow warm surface water to penetrate the density interface in progressive pulses, the anoxic seal will weaken. The hydrogen sulfide will react with the incoming oxygen. The Beggiatoa mat will lose its chemical substrate. The deepest 3,000 years of the sediment archive, sealed since the Bronze Age, preserved in perfect anoxic stillness, will oxygenate and degrade. This will not happen in a single event. It will happen in 24.8-hour tidal cycles, each one slightly more penetrating than the last over decades. By the time it is measurable, it will be irreversible. The 23 Hz signal at 5:17 a.m. has not been explained. The reef shark is still circling at 40 meters. The sediment floor is still recording. The pyrite crystal that took 3,000 years to grow to 0.8 millimeters is still on the floor, in the dark, in the sealed anoxic chamber, in the geological formation that has been here since before our species. We were here for 24 hours. We filmed what we could. The hole will record the rest without us.